Alright, hello and welcome to my general overview of ionic compounds. This is for regular chemistry. During this video, I will cover valence electrons, just a quick review, the octet rule, basic ionic compounds, the chemical formula, a little bit more complicated ionic compounds, and then naming these ionic compounds. Alright. So I want to start off by, I have a background here where I can draw stuff, and I will be swapping over to the periodic table as well. Get rid of that ad. I think I'll move this over to the side. Alright, so first we're going to begin with valence electrons. So I'm going to give us the detailed explanation for valence electrons, and then kind of the easy way to figure this out. Alright, so the gist of what a valence electron is. And can I type here? Stickers, eraser. Don't believe so. Alright. Valence electron is electrons in the outermost ring. Okay? That is a U. So that is what a valence electron is, and they are the ones that determine what type of ionic compound we are making, which is why we care about them. So if we were to take, just for example, say sodium right here, and we go to our periodic table, sodium has 11 electrons. So let's start with our rings. We have 11, and just to get that 11, here is our atomic number 11. 11 electrons. Here's our first ring. We have 2. Our second ring. 1, 2, 3, 4, 5, 6, 7, 8. So we are now at 2 plus 2 from our inner ring, 8 from our second ring, which means we have 10 total. And we are going to put our third electron in our third ring. This gives us 11 total electrons, and only this one as our valence electron. One valence electron. That's the more detailed way of getting it. Now, if we took magnesium, for example, magnesium has 12 electrons. We know this. We go back to our periodic table. Here is magnesium. Magnesium is 12. So we are adding one more electron from sodium. If we were to do this whole thing again, instead of, redoing all this, I can just add another electron. So magnesium, I just want to make this clear, will have 2 valence electrons when we add in another one. Alright? And if we were to go to our periodic table, we can start to see a trend. Here is sodium. It is in group 1. It has 1 valence electron. Magnesium over here is in group 2. It had 2 valence electrons. We're going to skip this entire section for now. Okay? We will skip down here. I will get to this section, or I will tell us about it, but we're going to skip this just for the moment. When we get over here to group 13, if we take aluminum with 13 electrons, sodium has 11 electrons and 1 valence electron. Magnesium has 12 electrons and 2 valence electrons. So with aluminum with 13, all we're doing is just adding another electron to this outermost ring. Would have 3 valence electrons. So we know here that aluminum will have 3 valence electrons. If we added another electron, 4, 5, 6, 7, and 8. The way you can easily get this, groups 1 and 2 tells you how many valence electrons there are. group 13, 14, 15, 16, 17, and 18, you just get rid of the 1. And that will tell you how many valence electrons each element in the group has. And this is really useful for elements like bromine here, right? Bromine, we did not, when we started doing it like this, and I told you, oh, well, you know, we're going to start filling up our rows, it gets a little complicated. This ring system really only starts to work for the first 20 elements, and then it starts getting complicated. But this way, you know that bromine will have 7 valence electrons. Iodine, down here, will have 7 valence electrons. Okay? And I'm going to clear our page here. When we are drawing our elements, we are going to draw Lewis dot structures. So we'll do this with these 4 elements. The ones I had just gone over. So I'm going to use VE. This is our valence electrons. 1, 2, 3, and 7. And we will start to draw in electrons. Notice how I draw them on different sides. 1, 2, 3, 4. So you're going to complete a circle around them, and then you will start to pair up our... Oh, I should not have an extra one. Notice how you start to pair up only after the first 4. This will be useful once we get on with our next chapter. So I do want to start that practice now. Alright, so we have a concept known as the octet rule. Octet rule. And this OCT, this oct means 8. And this term, I just wanted to look it up just to clarify. It comes from Latin, which is based off of Greek, and this means 8. Oct, so an octagon, just for example, has 1, 2, 3, 4, 5, 6, 7, 8 sides. Octagon, 8 sides. Alright? And what this means is that atoms, they want 8 valence electrons. I can write over here. Having 8 valence electrons means the atom is stable. And atoms want to be stable. Alright? So sometimes when we take an example of bromine right here, that's really easy to get. We have 7. We only need to put 1 more electron into bromine to make this stable. We already have 7. And when we do this, we're going to make a charged atom. The reason for this, if we looked at this mathematically, bromine, go back to our periodic table, has 35 protons. When it is no charge, it would have 35 electrons. 35 protons, 35 electrons. I just added another electron. Instead of 35, we now have 36 electrons. And the way that I've been going about this in class, because I think this is an easier way than having to do all this math and thinking about protons and adding them, we are adding. So I'm going to write this out. Add. I am adding a negative electron. Negative electron. As a reminder, I'm going to put this on the top right. Proton are positive. And electrons are negative. Okay? So we do not change the amount of protons, we change the amount of electrons. If we add a negative electron, we are adding a negative 1. So our charge, it started at 0. There was no charge in this. So 0 plus minus 1 gives us a charge of minus 1. So this atom becomes an ion, bromine with a minus 1 charge. Just as a quick note, I will only write a subtraction sign. I will not, when you use just a subtraction sign, we assume the charge is minus 1. Just as an example about this, You write x, you don't write x to the first. You'd write x to the second, but you don't write x to the first. Okay? So all of this is to get us to bromine. With a -1 charge, it now has 8 valence electrons. Sodium over here. You could 1, 2, 3, 4, 5, 6, 7, 8. You could add 7 electrons to this thing. And if you had enough energy, you could, but this won't last. Adding that many electrons, too much energy. Instead, there is a much easier route for sodium. Sodium can just get rid of this electron. Boom, gone. Now, sodium, if we were to actually look at its rings, so I will throw back to our sodium rings. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. By getting rid of that 1 electron, we now have 8 valence electrons. We're not going to write them in, but this shell is now full, and this would be stable. But because we have subtracted, we have subtracted a negative electron. So we started out with a charge of 0. We have subtracted a negative electron. When you subtract a negative number, you can make this into a positive, and this will become a +1 charge. And we will add as a +1. So go ahead. You can pause our video. I want you to think about what charges magnesium and aluminum will form. Alright? Okay. So I hope you've paused and done this work. Magnesium, it can either gain 6 or lose 2. Losing 2 is what we're going to do. So we get rid of these 2 electrons. So we are starting at 0. That's our charge. We're subtracting 2 negative electrons. So we will have a charge of +2. Aluminum, we're getting rid of 3 electrons. Because you could either gain 5 or lose 3. 0 minus -3 gives us a +3. And this will create aluminum 3+. So that's our first big major step, is getting to see what ions this will form when it has a clear and full octet. So I want to go back to our example with sodium, and I will use bromine because it works nicely here. We talked about sodium losing a valence electron, and bromine gains 1. And I kind of just said, oh, it's going to come out of thin air, right? I pulled up, oh, this one's going to come out of thin air, and just, we're just going to remove this one. Like, that's all we're doing. Instead of just, electrons doing nothing, what if sodium gives its single valence electron to bromine? We started with this, and we end up looking like this. Now, both of these atoms are happy. Sodium has 8 valence electrons under this shell, under this ring. Bromine has 8 valence electrons. Both of our atoms are happy, which means they are stable. But just because they are stable does not mean that they don't have a charge. We have a minus charge and a positive charge. This positive charge attracts to this negative charge. This will create what is known as an ionic bond. Alright, this is our first, really example of us putting together different atoms to create something new. We have now created sodium and a bromine as a salt together. So I pulled up an example. This is what this actually looks like. Um, this is sodium and the bromine together. It looks very similar to salt, but it is slightly different because table salt has chlorine, whereas this has bromine. Okay? So I just want to show you what this looks like. Now, when we write out our formula here, I kind of did it ahead of time, but we go with a certain pattern to write the formula. We always will take our positive ion and then the negative ion. We will always go in this order. So our positive ion is sodium, and it comes first. And we get rid of the charge. We get rid of our charge when we write it. We just write the element. Okay? So we just write the atomic symbol, sodium. And then we put our negative ion. Again, we get rid of the charge. And the reason for this, sodium has a positive 1 charge. The bromine has a -1 charge. If we were to add up these charges, we get 0. And we show that here. There is 0 charge on this ionic compound. Okay? And I should also say this is an ionic compound, which is a compound which is two or more different elements that are bonded together. And it is ionic because we have 2 ions, a positive and a negative ion. So that's a basic example. I want to bring up just another example really quickly as a more advanced example. So let's take, for example, we'll do, how about calcium and fluorine. So we go to our periodic table. Here's calcium, and here is fluorine. I'm going to erase all of these other ones so it's a little bit less confusing. So calcium is in group 2. So there are 2 valence electrons. Fluorine is in group 17. So there are 7 valence electrons. Okay? So calcium has 1, 2, and fluorine we have 1, 2, 3, 4, 5, 6, 7. So we're going to do what we did similarly before. Calcium is going to give this valence electron to fluorine. Fluorine now has 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. We have added a negative electron. Our charge will be -1. But this calcium, it still has this valence electron here. And it's not stable yet. So it's going to have to do something more. Instead of this calcium giving it away to this fluorine, we're going to add another fluorine atom that has 7 valence electrons. This calcium is going to give its valence electron to the fluorine. So now we have another fluorine that has a minus charge. Our calcium starts at a 0 charge. It is giving away, it is losing, so I'm using it as a negative, -2 charge, which means it has a positive 2 charge. So what we end up with is something that looks like this. Calcium with a 2+ with our ionic bond to a fluorine with a -1 charge connected to another fluorine with a -1 charge. Now, when we write our formula, we're going to start with our positive ion. Here's our positive. And we're going to do our negative ion. So we get CAF. But this doesn't tell us the whole story. We have 2 fluorine atoms. So we're going to write that down here as a 2. Alright? So I want you to do, as an example, I want you to do sodium and oxygen. Okay? I'm going to go to our periodic table. I'm going to I'm going to erase here. Here is sodium, and here is oxygen. I want you to do this example. I'll pause the video, try this out on your own. Okay, so here is sodium. It is in group 1, so it will have 1 valence electron. Oxygen, group 16, will have 6. Sodium with our 1. Oxygen, 1, 2, or 3, 4, 5, 6. So again, sodium will give up its 1 valence electron to oxygen. We are starting at a 0 charge. We are subtracting. We're losing a -1 charge. So this will become a sodium with a +1 charge. But this oxygen only has 7 valence electrons now. It needs 1 more electron. So we're going to bring another sodium here. With its 1 valence electron, it is going to fill the last spot. This will have a positive charge, like before. This oxygen starts at 0, and we are giving it 2 negatively charged electrons. -2. Alright, so our oxygen will have a -2 charge. Now, when we name this thing, I'm going to start with our positive ion, which is sodium. Then I will write our negative ion, which is oxygen. But again, we have 1, 2 sodiums. So we're going to write it like this. Okay? So when you see those little 2's that are down below, that means that that tells you how many atoms there are of that element. Now, the last thing I want to go over for today is how to name something. So I'm going to go back to the very first example that we had really gone through, which is NaBr. When you name this, you take your positive element's name. Okay? Our positive element. This is sodium. And then you're going to take your negative. So your negative element. You're going to cut off the ending. And you're going to add IDE to the end. So what do I mean by this? Let me show you as an example. So here's bromine. The ending of the word bromine is these 3 letters, I-N-E. So we are going to get rid of that. We now have brom, B-R-O-M. And we are going to add the letters I, D, and E. So our name for this ion will be called sodium bromide. Okay? That is all we are doing here. Just as another example, if we were to take our example from before, where we had sodium and oxygen. We would take sodium, again, that's the name of our positive ion, and oxygen. This one's a little bit, we cut off a lot here. We cut off the ending, oxygen. We just take the ox, and we add IDE. So we get sodium oxide. Okay? It doesn't matter how many there are. We still call it sodium oxide. When we are doing it, we know that sodium will always have a +1 charge. So we know that there would have to be 2, and we can calculate it, but this is what we will call it. So just as a list, if we go to the periodic table, the endings that I would expect us to know are for the following elements. Basically, these these elements. Okay? These are the 8 elements that I would ask about. It gets a little bit more complicated when we get to these other ones. So this would be So I would take nitrogen, and this will just become nitride. We just did oxygen. Fluorine. Instead of fluorine, it would become, we take off that ending there, fluoride. You may have heard about fluoride because that is what we put into toothpaste. For phosphorus, I'm going to pull this out all the way here. Phosphorus, we get rid of the ending here, and we will use phosphide. Like that. Sulfur will become, get rid of the ending, sulfide. Alright, and then these ones are, you just get rid of the INE, so we will get chloride, bromide, and iodide. Okay? So that is all for what I would expect us to know for now. We'll get a little bit more into this in our next chapter, or after this quiz as well. But this is all I'm really expecting for us for now. So again, if you have any questions, please do not hesitate to reach out. Have a wonderful day, and I hope that you do well on this quiz.